Hey guys, want to do another quick video here of the Universal Lipo Discharger Pro. We're going to go over in this video how to connect it to a battery, and we're also going to do a timed discharge cycle on a 6S 5000 milliamp battery. So first things first, what we want to do is take a look at the discharger itself. We can see here again, top, bottom fans. See some socket head screws here in the four corners. These are so you can actually adjust the discharger on a flat surface and just make sure it doesn't wobble or rock back and forth. We have the main battery leads, 14 gauge. They will be pre-tinned at the end. We just put this T connector on just for the video to show how it discharges. Our accessory port and then our balance lead port. Now, one major thing that outlines in the manual for this is how to connect the balance port from a battery to these pins. We have an extension here. You can see a male to female just for using the discharger. Now, this is a 6S. Rule of thumb would be, if we can get this in view here, is you have one side that has the little elevated notches for the keyed connector. The other side, if you look at it, you'll see all the little metal tabs that hold the connectors in the housing. Industry standard or rule of thumb would be this facing up would be negative at the very far left pin. So again, this would be connected in a way where negative is all the way to the very left-hand side. It's marked here with a little arrow, a little circle, and a couple negative signs, and it will also say it on the board as well as in the manual. So just want to cover that just so there's no confusion on how to connect it. So first things first, on our discharge test is we're going to test our battery. Use a little handheld battery checker here. Let's go ahead and connect it. Again, this is a 6S 5000 milliamp pack. See, we're at 97%. Use the first cell here for reference. We're at 4.164 or 4.16 volts. We're going to be checking that cell again when we've discharged. So again, we got a charged battery. We've got a stopwatch over here. We're going to leave in the frame and get it running once we start the discharge cycle. So again, in the manual, the first thing you'll want to do for the discharger is you'll want to go ahead and connect the battery to the discharger. Now obviously we have a T plug on here and a different connector, an EC5 style plug here. So we just have an adapter made. So again, in the manual, first things first, connect the battery to the discharger. There we go. Now you can see when we've done that, none of the lights in the discharger have illuminated. This is going to let us know that the discharger actually isn't doing anything yet. The discharger will not activate until we actually connect our balance plug from the battery to the discharger. And again, using a 12-inch long extension here. So what we'll do is we'll connect it first to the discharger. Again, as the manual states, negative of the battery balance connector is the furthest left pin on the discharger. Then just connect the battery to the extension or the discharger, depending on how you're doing it, and that will activate it depending on what the battery voltage is. Now, when we do this, there'll be a couple seconds delay until we can get the stopwatch started. But first things first, let's go ahead and get the battery connected up. We'll hit start on our stopwatch. We'll notice as soon as the battery was connected with the balance port is the fans on the discharger started running and the red LED turned on. This means now that the discharger is in discharge mode. So as it's going, it's pulling current from the battery through the main battery leads to the discharger. No discharging happens via the balance leads. These are solely for monitoring cell voltage themselves. So there's no current going through here, only through the main battery leads when it comes to discharging. Excuse me. Now, one of the features of the discharger is going to be that if everything connects up and nothing happens, you get no lights, no fans running, the discharger is not going to start until it sees a nominal cell voltage of about 3.6 volts or above. There's no sense for the discharger to turn on or activate at all if the battery is already at or below a storage voltage charge. Now what will happen is this discharge cycle will run when the microcontroller reads a nominal 3.85 volts per cell. At that point, the discharger, the red light will turn off, the green light will turn on, and the fans will continue to run. What that's going to tell us is that the discharger is no longer in discharge mode, and it's actually just running the fans to cool the device down. When we looked at it earlier, we saw it did have a heat sink, the dual cooling fans. Does emit some warm air just for cooling effect. On a 6S battery like this is pushing over 8 amps and over 200 watts of discharge power. So this is going to emit some heat, but the good thing is it's not emitting so much heat that if you touch the heat sink, it's going to burn you. You can touch it, you can feel that it's warm. I mean, if you keep your hands on there, it does get hot, but it's not the kind of hot that if you just barely rub against it, it's going to burn you. There is ample cooling. Another thing I want to make sure is while we're in the discharger is around the discharger, have nothing by it, just as a safety measure. Because of the warm air, we don't want to restrict the airflow. We don't want to actually have hot air coming off and going right back in. Definitely defeats the purpose of keeping it cooler. Another feature, which is a big safety feature for LiPo batteries, is so when the discharge cycle completes, that green LED turns on, the red one goes off, the fans are still running. Obviously, it takes a little bit of power to continue to run the fans. Now, typically in about a minute to a minute and a half, the discharger will already be cooled back down to an ambient temperature. But if for any reason you've forgotten that a battery was connected to the discharger and you're out doing something or you left and forgot about it, there is a safety feature built in that when the discharger will read 3.75 volts nominal cell voltage, the discharger will just completely shut down. LEDs won't be on, the fan will no longer run, and again, this is a safety feature to prevent any connected battery from over discharging. Now, the values for its turning on, turning off, storage voltage, etc., there is a slight 1% tolerance, plus or minus. Again, this is just due to the electronics and the tolerances of those. But we've seen very, very consistent results across the size of the batteries from 2S up to 7S. Now we can see our timer here, we're just at 4 minutes. Our red LED is still on, so we're still discharging. Again, discharging does happen through the main battery leads and not the balance leads. So we'll keep an eye on this. Again, timer's still going, fans are still running, and we just want to go ahead and keep an eye on the discharger and see how long it takes to discharge this 6S 5000 milliamp pack. We'll check back in a minute. We can see that our timer here is still going. We're going on 6 minutes and 45 seconds here. Again, a 6S, 5,000 milliamp pack we're discharging. Discharging happens through the main battery leads, not the balance leads. This size pack right now is discharging at over 8 amps and over 200 watts. Again, we are getting some heat off of here, but again, not too hot to where you can't touch it. Definitely you can touch the cooling fans, the cooling fins on the heat sink. They are warm. If you hold your hand on there longer, it does get quite warm, but not hot in the sense where it's going to burn you just by touching it or brushing against it. Again, red LEDs on. We're still discharge cycling here. Both top and bottom fans are running. Again, this is for keeping the device cool just based on the amount of heat it puts out, especially for the larger packs. The device, again, is universal. It'll do 2S to 7S. The specs are on the website, www.perfectregulators.com, and you can just look at the Universal Lipo Discharger Pro. On that product page, you'll be able to see specifications for the max current draw through the discharger for the connected battery of what you're going to discharge. Here we're going on 8 minutes, 10 seconds. Still discharging. We'll go ahead and check back in a minute. All right, as we can see now, our timer here, we're just over 10 minutes. Still discharging. Fans are still running. Device will actually, believe it or not, as it's going and longer, it doesn't get hotter and hotter. Usually within the first about minute and a half or so, the maximum temperature usually is reached by what the device is going to emit heat-wise. Again, it does do this because, again, on a 6S 5000 or even just a 6S 1800 or any 6S size lithium polymer or LiPo battery, we're going to be pulling the same amount of current in watts. Just depending on the size of the battery will determine how quick or how long it takes. Now, one good feature is most of our our chargers that we use have a battery discharge or battery storage charge feature to discharge batteries. The only drawback to that is while they work, they take forever. Majority of them are limited to 80 watts internal, or even a few of them have 100 watts internal. So the standalone discharger itself here, self-contained, don't have to use electricity, just plug your battery in and run it. It'll automatically get to a nominal storage voltage, and then the device just shuts itself off. Again, it's all about battery safety and battery management. Again, we can see our timer is still going here. We're at 11 minutes and 30 seconds. We are still red LED, so we are still discharging at this time. We'll keep an eye on it and see how long it takes. All right, let's go ahead and stop our stopwatch here. We're roughly 12 minutes and 45 seconds. You'll notice the red LED turned off, the green LED turned on. This just indicated that the battery discharge cycle is completed. There is no more current being drawn through the main battery leads, only the fans running. And again, the fans will continue to run until either the device itself reads a battery voltage of 3.75 volts, or you just simply disconnect the battery from the discharger. Typically about a minute and a half of the fans running after the discharge cycle is completed really will cool the entire discharger back down to an ambient temperature. You can see it now. I mean, it's cooled it down enough where I can actually hold this by the heat sink, and while it's warm, it's definitely warm to continue to handle. Excuse me. So we can see now, again, discharging is done. No longer through pulling current from the battery. We should be at approximately 3.85 volts plus or minus 1% up or down. So let's go ahead now. Make sure this just gets a little bit cooler. Now, the cool thing is, while this is cooling down a little bit, we notice our timer was at 12 minutes and about 45 seconds for our discharge cycle. That's actually a really great time, considering we've personally seen, even on a 100-watt internal discharge capability on a high-end charger, this same battery can take approximately 32 to 35 minutes based on exactly how fully charged it is. And we've seen it was pretty much fully charged. We're like about 96% or 97%, I believe. So we've really, at that point, off of 32 to 35 minutes, we are definitely less than half the time that would have taken. This would also indicate to us that even on a charger that does 80-watt internal discharge, we're going to be way less amount of time spent discharging our batteries or putting our batteries into a storage charge mode here. So let's go ahead now, disconnect the discharger. Can be done either way. We'll just go ahead and disconnect the balance lead. Notice the fans and the LED shut off. That's because now the microcontroller has no reference of cell voltage to be able to continue to run. So we'll go ahead and disconnect that. We'll disconnect our battery. Okay. We'll get our little cell tester out here. Get our battery. We'll get it connected and see what we're sitting at. Excuse me. You can see based off of this, we're sitting at 55%. Again, we're going to check that first cell for reference and see, well, look at that. We're at 3.852 volts. So our battery right now is safely at a storage charge. We can easily take it, put it in our battery case, charge box, or wherever we store this battery, and it is now safe to be stored without being fully charged and not over discharged. So again, 12 minutes and 45 seconds to take a fully charged 6S 5000 pack and put it at 3.85 volt storage charge. All by using a simple, standalone, self-contained Lipo battery discharger. If you guys have any questions, feel free to contact us at www.perfectregulators.com. Thanks for watching.